Today I'm going to talk about China OTT, and this is a case study. And again, I'm Reza Rassool, CTO of RealNetworks. I've been 2 years in the job, and at RealNetworks, two broad areas of development report to me: the codec development, which is based in China, hence the case study, and machine learning, which is a new initiative within RealNetworks, about a year and a half old, where we not only encode video, but we analyze it to find the deeper content in the video. So today we're going to talk about, we'll give you an update on RealNetworks. You know, when I took the job, lots of people asked me, RealNetworks, is that still a thing? And so I'm going to give you an update on that. And then it's a cliche that everything's growing very fast in China. Well, OTT is growing fast, and I'll provide you the numbers on that. Describe the challenges facing harnessing that growth and the opportunities that can be reaped from positioning yourself in that market. The takeaway from today's talk would be, one, that China actually leads the way in OTT, and that the Real Media codec, we call Real Media HD, is a software codec that outperforms HEVC. The two things are tied together, and the deck will explain how they're tied together. So RealNetworks, 20 years of innovation. When the Earth's crust was cooling, many of you in this audience probably used a real player at one time or other in your career for work and for entertainment. RealNetworks, arguably the inventor of streaming media, originated the first streaming media protocol. First audio streaming and then video streaming. In fact, the audio streaming technology went on to power the music service Rhapsody. Rhapsody is now called Napster. Just a data point, Napster is the only profitable music streaming service in the entire space. All the others are growing, are large, but are loss-making. RealNetworks went on to power end-to-end streaming services, video streaming services. I heard a lot of the speakers today rather nostalgic about the session-based protocols, and I'll touch more upon that later on. The codec development went through many versions. We're up to version 11, and I'll tell you about version 11. But at 2014, we reached a point where we'd sold 1 billion codecs. We're now at about 1.8 billion. Many of those codecs are probably in landfills. That's how RealNetworks makes its revenue, through the royalties of codecs on a per-device basis, mostly in the China market. I'll not touch on it here, but the reason we're hardly known of in the West is historical. There was a court case that was fought about it. There was an out-of-court settlement where Microsoft paid us a reasonable amount of money for the anti-competitive practice. But in the marketplace where we were allowed to thrive in China, the Real Media codec became the de facto codec. De facto codec of China. Even today, 38% of content downloaded from the internet uses a Real Media codec of one version or another. And the codec is widely deployed in devices like smart TVs, mobile phones, set-top boxes. And I'm going to give you an update on how that codec is solving real-world problems in the OTT space. Just as an aside, RealNetworks also has a gaming business, and that business runs out of Eindhoven. So a full digital entertainment technology company games, video, and audio. So the company that invented streaming media continues to innovate digital media technologies. But as I said, this is about China. So we're strong in China. The office was established in 2005, licensed 1 billion codecs by 2014. We're now up to version 11. It's part of the Huawei mobile operating system. So that huge number of mobile handsets benefits from the codec at a native level, but the codec can be deployed at an app level as well, which is very rare. Codecs of this generation normally require hardware to decode, and they're not getting any simpler even when we go to 266 or to AV1. And then today we're going to talk specifically about one use case where the Real Media HD codec was adopted by the number 3 OTT in China called CIBN, the government-owned operator. So by the numbers, let's look at the numbers. What does it tell us? It tells us that even though the internet adoption started late in China, it's moving very, very fast. The graph on the top left shows us that even today it outpaces the rest of the world by a handsome margin. 3 times more internet usage in China than in the United States. But it's not only the fact that it's large, it's the fact that it's growing. And the dimensions of growth in the bottom left show that even though it's growing, it's still got more room for growth. In fact, if we highlight the same period and compare China to the US, if we compare the years from 2007 to 2016, we see a very interesting story. In 2007 to 2016, the US internet penetration plateaued at around about 75%, whereas in China, we're still experiencing a growth there, and it looks like there's plenty more headroom for further growth. And then if we look at the top right, we look at the spread of device usage for the internet. Where are people accessing the internet, and on what device and on what screen? Well, the story from this is China has gone mobile in a very, very strong way. And they've gone mobile in many, many more ways than you'd expect, not just in the consumption of the internet. Mobile payment is now the predominant way that you pay. They've jumped over the credit card phase, and more often than not, you'd go into a store, someone would take out their phone and do a WeChat payment transaction, and that is the norm. Let's move on. So we said internet consumption is booming in China. Well, OTT video is booming in China as well. I can make these graphs available to anyone that contacts me. I can send a copy of this, so no need to record any of this. But an OTT subscriber population as big as the entire population of the US. I mean, it's a phenomenal number, and it appears to be growing. Here are the big players. Tencent, iQIYI, and Youku CIBN. Look how these names are dashed. Youku and CIBN are 2 different companies. Why are we connecting the 2 together in a service offering? And that comes more into play as I describe to you how the market is regulated and how you have to create these operating partnerships in order to serve up content in the China market. So there's very, very strict regulation in China. and that regulation has recently undergone a change just after the last Congress meeting. And there was an entity called SARFT, S-A-R-F-T. It's now replaced by an administration called SART, S-A-R-T. It regulates who can create content. So all studios need to get a SART license. All content aggregators need to get a SART license, and only 7 licenses have been granted. So those 7 licensees are in an extremely important and influential position, and virtually every operator has to partner with one of those 7 in order to operate a service in China. And then the streaming service operators, a small number, a bit more, 588 service operating licenses were granted many years ago. RealNetworks has one of those. Which is very rare for a US company, but it was in the early days, and it's a testament to some extent that RealNetworks is almost regarded as a local company. We've been there a long time. We are strenuous to abide by the local regime, the regimen of regulations, and it's also a testament to the network that we've built up in the country. So the onus is upon the aggregators and the content creators and the operators to abide by the regulations of their licenses, and here's a sort of a graphic of how they are connected. A large responsibility is to make sure that content is adequately filtered and censored according to the regulations. Here is a description of how you have to, and how many of the players have formed partnerships through one of the 7 aggregators. And I could share this a bit more. It's interesting to note that CIBN is directly owned by the government. So that's the equivalent of the national broadcaster. So there are restrictions, and it's very difficult from outside of the country to actually navigate through this set of restrictions. One of the restrictions is the restriction on getting foreign content into the country. There is a quota system, and so if you're an operator and you want to serve Hollywood content, for every 30 Hollywood titles that you license to serve through your service, you have to have licensed 70 local titles. And so many operators are having to fund local content acquisition in order to serve a foreign and international menu of titles. Let's talk about CIBN. CIBN's our latest design win. It's a fairly large OTT operator. Just by the US dimensions, it's large. 32 million active subscribers, 110 million devices on their network. And they're the number 3 player in the space. So that's phenomenal. And we were talking, some of the previous panelists were talking about the problems of scale. Let me tell you, these problems are very real in the China market. The problems of scale are very large. In their network, when they analyze their network, they find that there are about 74 different devices connected to their network. And this is one of the important things when the industry moved from IPTV to OTT, the operator lost control of the device. In the IPTV days, the operator would typically own the device. There'd be a truck roll or some sort of rental system where the device would be rented to the subscriber. In the OTT world, the subscriber goes off to their local electronics store, buys their own device, let's say in the US a Fire TV, a Roku, even an Xbox, and they connect that device up to the network and install an app. And that's the time when the operator discovers the capabilities of the device that they're supposed to be serving to. They discover what hardware codec is available on that device, so they know what to serve. This becomes a huge problem in a large network of disparate devices with disparate capabilities where the operator doesn't have control over it. So you have to come up with a solution that's capable to respond and adapt to a changing, fragmented device landscape. The other design win is Stars China, which is a mobile operator. And whereas CIBN was an operator serving up to set-top boxes, Stars China serves up to mobile customers. Huge numbers as well. 240 million registered users with 2 million daily actives. And it was interesting in the previous panel, I heard the comment and I questioned on the notion of the hub and spoke topology. The hub and spoke topology at the China scale just does not work. There is not enough CDN capacity to handle the space. But they've come up with innovative ways of solving the problem in a hybrid CDN P2P topology, which is revolutionary. I mean, it's groundbreaking, and it's a topology that will come to the West because they're having to solve the problem in smarter ways, given the infrastructure that's available. So, in the photograph, I wonder if any of you recognize my boss, Rob Glazer, over there. He's shaking hands with Mr. Gong, CEO of CIBN, who set us some ambitious requirements. He described, okay, here's the CIBN problem. We've got this huge number of customers. We've got this fragmented device landscape. We want to improve our service quality. They were serving 720p at 2.5 megabits. We want to improve our service quality, but we want to also reduce our CDN bill. CDN bill is the number 2 bill for most OTTs after content acquisition. And they want to get wider coverage. They don't want to just be limited to the devices that have the latest hardware codec pre-installed or in their device. And then as a side benefit, the fact that we had a video license allowed us to handshake on a partnership to participate in a content service. So we've got a deep relationship with CIBN, and we're providing them with technology to help solve these problems. And so this is another articulation of those problems. They want to improve video quality. They want to improve streaming performance. They want to reduce their CDN costs, and they want to regain codec control. So how did Real solve the problem? Well, we solved it with a software codec. Ludicrous, people would say. You can't decode video with a software codec on a mobile processor, on a lightweight set-top box. Well, we challenged our codec engineers some 4 years ago, 5 years ago, to solve the codec problem in a different way to the MPEG designed by committee approach, and come up with a lightweight, lean and mean codec solution that didn't solve all the problems of video, but just focused on very simply encoding and decoding video. And the aim was to solve it and come up with a solution that could decode on a mobile processor up to 4K video at full frame rate. And the goal was to be competitive with HEVC. So it was an ambitious goal. We started to get glimmerings of success by 2015, 2014, 2015. By 2016, we were ahead of AVC 264. By 2018, we can announce dramatic improvement in the performance. And there's still more improvement to come. But at this point, we can declare success in the initial ambitions. So it's available as an Android SDK or as an iOS SDK on the client side to build into your OTT app. And the encoder, well, we've been releasing the encoder free to consumers in Windows. For professional purposes, a Linux version is also available, and it's smaller. It results in a smaller file than HEVC, and it encodes faster. So it's software-defined codec for a software-defined network. Moore's law wins out in the end. The Intel presentation is a good illustration that each year compute power is going to double. Memory capacity is going to double. Storage is going to reduce in price and become more efficient. And so banking on Moore's law, you win every time. Not only do you get a result that is going to outperform hardware in the long run, you get to market a lot quicker than hardware. And you end up with a solution that's more agile and more responsive to market needs should they change. The other important factor for OTT in particular is you get greater device coverage. Any device with a CPU can run the software. Waiting until an AVC or an HEVC or even an AV1 hardware decoder is available and ubiquitously deployed in your subscriber base is too long. It's simply too long if you're in a rapidly growing marketplace that's not waiting for anyone. You need a software solution now. So how does it perform on compression? Well, at 1080p, it does pretty damn well. It outperforms AVC. That's not too difficult. AVC is a 10-year-old codec. Outperforms it by about 40%. Specific to CIBN, they were delivering 720p at 2.5 megabits. We took them to 1080p at 1.5 megabits. So we achieved their goal of being able to increase their service quality while decreasing their CDN bill 40%. They also said they wanted a hedge against HEVC. And so we provided them with a solution that matched HEVC at 2 megabits a second for quality. Anything above 2 megabits, we actually outperform HEVC. So this is the 1080p data. But what happens when we go up even further to 4K? This is where the Real Media codec really gets into its stride. At 4K, it outperforms the landscape of incumbents in the space. You get a 60% saving over AVC, and you get a 25% saving over HEVC. And this is taking the data, the VMAF quality point of 88, which is the quality that Netflix serves at. It serves its 4K service at a VMAF of 88. Of course, if you want to take the VMAF score even higher and deliver a higher quality product, you get even better proportional savings. So it sounds too good to be true. I'll have to give you a demo. But before I give you the demo, I'm going to hark back to RealNetworks' original streaming protocol. We were the authors of RTSP. And so much of the learning from RTSP, we resurrected. We understood how to manage buffers. We understood the streaming logic. And that, one of the speakers lamented that perhaps we threw the baby out with the bathwater when we went from server-side streaming protocols to the dumb server, the dumb HTTP server, where all the buffering logic is now on the client. Yeah, we perhaps did, but let's not cry over spilt milk. What we did was we resurrected that buffering logic and implemented it in a faster HLS streaming client. And the interesting thing, before I give you this demo, about a low complexity codec and the way we achieved our low complexity codec ended up with an ability to take the chunk size of streaming down to very, very small levels. And I don't want to go into the details of how we did that, but it results in a more streamable stream. More streamable movie with faster startup, faster seeking, lower latency, and one that is more cache friendly at the CDN. So I'm going to give you a demo, and in order to do that, we're just going to do a bit of cable shuffling. So this might be a bit loud. So this is a 4K video at 4.8 megabits a second. Unfortunately, the projector is only a 1080p projector, but if you want to come and see it on my iPad, it's in. So I'll play this for a little bit, and then I'll show you some other content. And then I have this also running on an Android phone, streaming from China now, and I've got it on iOS as well. So we can listen to more, and I'm going to pause there and perhaps open it up for questions. Or I can play some more videos. Okay, I've got a question from over here.
The savings in bit rates and all that sounds great, but for these types of aspects for software, the key is the processing that it uses on the client,
right.
The battery it uses on the client, all the resources that it
yeah.
uses to run on the client. Do you have any key data on those aspects?
Yes, indeed. So on the Huawei Mate 9 phone, which is a 2-year-old Huawei phone, it uses 8% more CPU than H.264 decoding. So that means that if you were to be playing a movie, and this is how we test it, we play a movie, we have a movie playing in a loop, the H.264 version of it, until the battery runs flat. And then we do it with the Real Media codec. We run it until the battery runs flat. And the difference in duration, it's like 7 hours to 7 hours, 35 minutes. The H.264 lasted an extra 35 minutes compared to decoding in real media. Turns out that the CPUs are way powerful enough now. Moore's law wins out again. Thank you to the man from Intel in the corner. It's actually the display that's using up most of the battery. In fact, when we take the display brightness down to 50%, the battery lasts twice as long. So, good question. It's one that nagged us in the early days. I have to say, in 2014, 2015, we were really worried about battery consumption, but now we're not worried about battery consumption. I've got a few questions over here. Let's take this one here, sir.
Just for reference, in terms of the scalability in China, are you seeing more, are we transitioning to IP6 there, or are we still on IP4?
It's still IP4. I don't know that IP6 is going to. It's something that's. I don't know that it's affecting the market in any way. I think the thing that's looming faster though is probably 5G, and so our discussions with our Chinese partners is more around how does the codec support 5G and how is it friendly to that, which actually dovetails into the peer-to-peer topology very strongly, and that's subject of another talk. I had a question just over here.
Is there any support for quantum acceleration?
Yes, indeed, right. So with the typical way in which we license is we with handset manufacturers is we partner with the OEM and we integrate into their operating system. And so at that point, they reveal to us the undocumented video hardware capabilities. Yeah.
My question is about encoding design, right? So when we encode into the multiple profiles,
Yeah.
use the GPUs.
Yeah, absolutely. At the moment, we're all CPU-based. There's lots of scoping for acceleration. We currently encode about twice as fast as 265. I can give you the encoding numbers. That was the subject of a whole other set of graphs. Outperforms VP9 in encoding.